Bristol Community College, Mathematics with Dan Avedikian, Math 011, Arithmetic, Section 2.5, Problem 20. This is Section 2.5, Problem 20. It says divide the fractions, and we have 2 1/3 over 5 4/9. So let me start by writing the problem in a little different format. I'll write 2 1/3 divided by 5 4/9. This is the same problem, but in its original form it looks much more intimidating. This is what you would call a complex fraction. You have a fraction over a fraction. Now that I have it written in this form, it doesn't seem quite as bad. The next thing I need to do is rewrite the problem so it doesn't have mixed numbers in it, but improper fractions instead. So start with the 2 1/3. I will come from the bottom and multiply times the whole number in front. So I will multiply 3 times 2, which is equal to 6. And then I will take that result of 6 and I will add it to the numerator. So I have 6 plus 1 more for the numerator, which gives me a result of 7. So 2 1/3 can be written as 7/3. That's an equivalent amount. I'll leave the division for the time being. And now 5 4/9 also needs to be changed to an improper fraction. So do the same process. Multiply the denominator times the whole number in front. So I will multiply 9 times 5, which is 45. And then I'll take the result that I get and add it to the numerator. So I will add 45 plus 4 more for my numerator. 45 plus 4 more gives me a result of 49. So 5 4/9 can be rewritten as 49 over 9. Now what I will do is rewrite this problem again as a multiplication. So the first fraction, 7/3, can stay 7/3. The division gets changed to a multiplication, and the second fraction, the 49 over 9, is inverted and changed to 9 over 49. And now I can multiply. Top times top, bottom times bottom. I can get the answer, and it would have to be reduced. Looking at this, especially where the numbers are somewhat big, it's in my best interest to pre-reduce this. Notice the 49 and the 7 reduce nicely. The 9 and the 3 reduce nicely. So let me go ahead and do that. 7 goes into 7 once. 7 goes into 49 7 times. And the 3 goes into 3 once, 3 goes into 9 3 times. So now on the top, the numerator times numerator becomes 1 times 3, which is 3. And in the bottom, the denominator times denominator is 1 times 7, which is 7. So the answer comes out to 3 over 7. Now if I had multiplied 7 times 9, and then that would be 63 over 3 times 49, which I think is 147, and you reduce it, it would reduce to the same 3 over 7. But pre-reducing is much easier.